Hello and welcome to the Math Bender. I'm Adnan Zadi, and in this section we'll discuss an extension of logarithmic law, which is change of the base law. So let's see what change of the base law means. So if I write anything like this, log 2 of 3, then this law model is of base 2. If I write log 3, this log without writing anything as here, this is understood as base 10. So if I want to write down, or if I want to see an expression like this, I cannot interact both of them because they belong to different creed. They have a different base overall. So if I want them to interact, they need to have a same base, and hence if I see log 2 of 3, let me write down the value. So log 2 of 3, if I write that down, so log 2 of 3 can be written as 1.58. Let me write that down. Alright, this can be also written as 1 over log 3 of 2 as a denominator. So 1 over log 3 of 2 will give you the same value as the previous one, 1.58. Not only that, you can also split them and introduce a third log, which is, let's say, log 10 of 3 over log 10 of 2. It gives you the same value. Moreover, you can also write this as natural log 3 over natural log 2. So you can express it any way you want to. So hence all of them have the same values. So I can write them as a law, and log a of b, if I want to generalize it, can be written as 1 over log b of a, or I can also write them as lgb over lga. I'm just taking lg as log base 10, but you can write as ln b over ln a, or any third log you want to introduce. Let's say log 3 of b over log 3 of a. You can express it as you like it. So let's see some of the examples where they are applied. So here, as you could see that here they both are related in a manner where one is base, the other one is right there, and hence there is a change. So I can write this one as log 5 of y can also, and 4 over, if I take this as denominator, I can write this as log 5 of y, because log a of b is as same as 1 over log b of a. So let's take log 5 of y for a moment. Log 5 of y as x. I can write this as x is equals to 4 over x, and hence x squared is equals to 4. Moreover, x is equals to root 4, which is plus and a minus 2. Now since we already had taken a substitution, x is 2 or a minus 2. If I write log 5 of y is equals to 2, or log 5 of y is equals to negative 2. Taking the anti-log both sides will give you y is equals to, this becomes 5 squared, and y is equals to 5 to the power negative 2. Y is equals to 25 and y is equals to 1 over 25. Let's look at another example here. So as you could see that p is log q of 32 and you have to express this thing in terms of p. Now the problem here is that we need to log q of 4, we need to check what log q of 4 is. So expressing them, p is equals to log q of 32, and I can say log q of, now 32 and 4, they don't interact directly, but they do interact because 4 is 2 squared and 32 is 2 to the power 5. So if I convert both the numbers in a power where they both can meet each other, so I can say log q of 4 is as same as log q of 2 square, and 2 times log q of 2, and hence p can be written as 2 to the power of 5. So p is equals to 5 times log q of 2, and log q of 2 can be written as p over 5. And since we already had established that log q of 4 is as same as 2 times log q of 2, 2 times, instead of log q of 2 I can replace it with p over 5, and hence 2p over 5. Let's see another one. First step, expand it. Log q of 16 plus log q of q. And I can say this as log q of 4 square plus log q of q turns out to be 1. 2 times log q of 4 plus 1. And hence, since log q of 4 we already figured out here as 2 times p over 5. So 2 times, instead of log q of 4 I replace it with 2p over 5 plus 1, gives you 4p over 5 plus 1. Let's look at this example. Log 9 of y is x. So I can write this one as 1 over log 9 of y, or 1 over x, applying the change of base law. Let's look at the other example here. For b, I can write this as log 9 of 9 plus log 9 of y. If you want to catch up with this law, which is I use the product law, you may want to view the first videos before this one. So log 9 of 9 is 1 plus log 9 of y is already given as x. For the third one, it's log 3 of y. Okay, so in order to solve this one, you need to first review this one. The reason being that the base is 9 here and the base is 3 here. So I can write this as the first one, log 9 of y is equals to x. Let's look at this one first. I can write this as log y over log 9 is equals to x. And I can also write this as log y over log 3 squared, hence becomes log y over 2 log 3. Now writing that again, so 1 over 2 times log y over log 3 is equals to x. And you can say that 1 over 2 log 3 of y, replacing this back to its law, which was log a of b can be written as log of b over log of a. It could be either way, is equals to x, and log 3 of y is equals to 2x. The same way, let's look at this example. Log 3 of 81 plus log 3 of y. I can write this as log 3 of 3 to the power of 4 plus log 3 of y. We already saw log 3 of y, which is 2x. So 4 times log 3 of 3, this power multiplies, plus log 3 of y is already 2x. So it's going to be 4 plus 2x. Let's look at an example. All you have to express them as base 3. So whenever you have a complicated situation like this, it's always better to get back to basics. So first step, write this down into its basic form, log p over log 2. Note that I'm always using log base 10 whenever I'm applying the base law, but you can use any other law. I'm comfortable using that. It's my own prerogative. So log 2 over log 3 plus, I change that as well here. Now this is log 3 of q, leaving it as it is, because I need to get over with the first one. So I can cancel these log 2's, and I'm left with log p over log base 10, 3 plus log 3 of q. Now look at this one, and you can write this change of base law. As you know, log a of b is as same as log b over log a. And I can write this as log 3 of b plus log 3 of q. Now, log 3, since they are adding up, becomes pq. I use the product rule where log a of x plus log a of y can also be written as log a of x times y. Now let's look at another question here. You have to solve the equation where they both are related in such a manner that I can easily see that the base are different, but they're connected. So if I can, first step, I can write this as log a of x plus 3, taking that in denominator, hence become log a of x is equals to 4. Now rather than taking logs right just like this, it's better that you take substitutions. So if I take let log a of x is equals to y for a moment, and I can write this as y is equals to y plus 3 over y is equals to 4. And y squared plus 3 is equals to 4y. I just took the LCM. I'll rewrite it. So, as you know that this is 1, in order to make a common denominator, it should be multiplied with y. And hence, y squared plus 3 over y is equals to 4. And when you multiply this over there, becomes y squared plus 3 is equals to 4y, hence making a quadratic equation. And then you know that y squared minus 3y minus y plus 3 equals to 0. And if you take y common, becomes minus 3. And if here you take negative 1 common, becomes y minus 3 equals to 0. Y turns out to be 1, y turns out to be 2. So let's replace y with its x. So we know that since we took log a of y as equals to y, log a of x is equals to y. So log a of x is equals to 1 and log a of x is equals to 3. So x is equals to a to the power of 1, taking the antilog, and x is equals to a to the power of 3. These are the two answers. I hope I've made myself clear in this one. Do write in comments if you need any, if you have any suggestions or you want me to solve any of the further questions. Until then, take care. Bye.